Okay, good afternoon, everyone. Those who already joined and those who might be joining as we go moving forward. This is the day two for Australian Software Engineering Week, hosted by and organized by UTS School of Computer Science and Discipline Software Engineering. Myself is Avinash Singh, one of the co-hosts with Ining and Professor Asif Gill, who is the organizer of this event. And we have an amazing guest with us today, Keynote, Dr. Liming Zhu. Dr. Liming Zhu is a director of Data 61. If I'm not wrong, the CSIRO unit focus more around data and software engineering. You can correct me if I'm wrong. Mostly focus, so Dr. Liming Zhu leads CSIRO Data 61, focus on digital and AI arm of Australian National Science Agency, which is a CSIRO, and is also co-joint professor at UNSW. He's a recognized leader. Lots of you working in software engineering and AI might came across his name, I assume, in AI engineering, and most importantly, and I think important field of responsible AI. He operates in the intersection of AI research, national capability, global governance, and also represent Australia in National AI Safety Science Report, contributed to OECD and AI on risk and accountability, ISO, AI and standard, and so on. It's a list long. Obviously, Dr. Zhu also published a lot. So if you're interested in his work, you might want to check out lots of publication, which is more than hundreds or 400 plus, at least what I can read on the bio, but I believe they continue growing in the field of software engineering and responsible AI. He also have a book called Responsible AI Best Practices for Creating Trustworthy AI System and Engineering AI System. It would be very nice, especially emerging researcher and developer in the field of system and engineering or software engineering, especially might be good to check out when we're dealing and talking about responsible AI and also how AI might affect you, how this will impact not just an individual, but also the system engineering. So I'm really, really happy to welcome Dr. Liming Zhu for today's keynote lecture. And Dr. Liming Zhu, whenever you're ready, thank you
All
for
right.
coming. Yes.
Thanks very much for having me, and great thanks, Asif, to inviting me to this event. Happy to talk to you about this topic on agentic software engineering. I think, depending on what you have been expecting, to some, agentic software engineering means probably vibe coding. How do I use coding agents to write code? And we use agents to write code more and more. I think the elite programmers these days, they all kind of trying to see how many agents they can launch at the same time, the 8, 16, writing thousands of lines of code in minutes. And the human are no longer involved in reading every lines of code, and its productivity is dramatically improving. But for others, maybe it's more about how do we use software engineering to build agents that does all sorts of tasks, um, starting from a conversational kind of bot to a really true agentic system. And those agents are very autonomous, can do a lot of things. Humans are overseeing them, interacting with them, but what exactly the humans are doing and the human oversight is designed is another question. So I probably will be a little bit more on the general how to build a proper agentic system with human involvement rather than teaching you how to do vibe coding today. All right, so it's always people start with a definition and maybe people find it very boring. So I put the title as a strange evolution of definitions of AI systems. So when we if you go any organizations, you go to Australian's Department of Industry, OECD, they have a definition of AI. And many people didn't notice they changed the definition in the last couple of years. So initially they have this AI system is a designed machine-based system for a given set of human defined explicit objectives, etc., etc. But they removed the word designed because I think many of the people will know or argue these days AI, especially general purpose AI, ChatGPT-like foundation models are not designed by human. People compare it with a growing alien seed. You know, you have a very simple learning algorithm, learning objective, predicting the next word. You give it a lot of data, compute, a system is grown out of it. Nobody designed for to write a poem, writing code, writing essay. It just the capabilities emerges, and you try to understand it by through evaluation to say, look, can the system do this? Oh, surprisingly, very well. Can the system do that? Not very well. Can we improve that? And even for improvement, you don't go back to design your AI system in any meaningful way. You give them a little bit more data here, a little bit more data there, hopefully to steer the growth into the desired probability. So it's no longer a design system. Also, remove the human-defined objective completely because we all know agents, they can pursue their own goals in a way. Sometimes you say, okay, I give it a goal called make me a funny picture, but how they decompose that goal into sub goals and figuring out the way to create a funny picture, they can do a lot of things. Of course, the high level goals are given by human, but that high level goals are so kind of vague and abstract, it's not that meaningful in terms of how the AI, agentic AI, does things. So they can do a lot of things. You ask them to make paper clips, and they may go around and turning, as the story tells, turning all humans into the resources to making paper clips. Anyway, so I think there's a lot of the human's role is being removed from definition, alarmingly to some, and maybe to the people who didn't realize this change, I still think it's a reasonable definition. And of course, AI system not only producing contents, it produces predictions, recommendations, and decisions, which affects everybody. And it can change after deployment, the adaptiveness after deployment. What does it mean? People say, yeah, I build adaptive systems. There's a lot of systems with predefined if-else conditions reading from the environment, and they change, they adapt. But I think adaptiveness here is much more profound than if-else conditions, no matter how many of them you have written, predefined and reacting to predictable environment changes. And also, I think it's very important to understand AI system as what's the model and what's the system and agent. So in this diagram from Australian's AI safety kind of guidance, you can see actually the foundation model, the general purpose AI, the sort of the agentic, enabling the agentic AI revolution is just the one component out of the whole system. You're combining these general purpose foundation models with narrow AI models, with non-AI components. You not only have training data to deal with, but also have inference data to deal with. You have guardrails around them, everything to form the holistic system. As I often say, the prompt you submit to ChatGPT never goes to the model directly. It goes through a system of systems of filters and stuff before it even reaches the system. So that whole system actually is the one having an impact on us rather than the underlying model. Since we're talking about agentic, so I think it's worth to say what is agency. So there's a lot of definitions of that. I think I want to probably doesn't matter, sometimes if the agent is very can adapt to the environment. Well, any system can adapt to the environment. A complex business process engine can adapt to environment. I would say pursuing goals, yeah. I would say any AI, any software system is sort of pursuing a goal you have predefined. So what is the agency? So the agency is really, in a lot of definition, is your genuine capacity to steer outcomes towards a goal. The importance is genuine, not illusion. Let me tell you what I see by illusion um, and why some of the characteristics of agent is sort of starting to blur. So first, the boundary problem is very obvious. You are using an agent or AI to do something. Is that really you doing it or the agent doing it? There's a philosophical discussion back in the 1960s, even to the early classical period on if you are using a tool to do something, is that you doing it or the tool doing it? Especially if the tool have a lot of agency in it, have the real capacity to steer. So maybe there's a question in there. The other one is goal direction. People say, I set the goals. I utter the word fix that bug. And that's why I'm responsible for everything. Fix the bug. I just have to utter that word. And if it doesn't fix, I will say, fix the bug again, do it again, try it again. I mean, sure, you can say, because you uttered that word, you are responsible for everything. You claim all the credits, but is that really that you are giving any meaningful agency to the way to fix it? And actually, a lot of the prompt engineering are telling you, don't tell AI what to do. Just by shouting, making it more interesting 10 times, you'll get better results. Don't try to be smart to say, make it interesting in that way, make it interesting in that way. No, just say, make it more interesting. I think online on X and Twitter, you see a lot of people trying to do that to an AI picture, and it gets very interesting results without you telling them what is interesting. So goal directness really requires on that level of genuine steer. The other one is the illusion of control of the effort in prompting AI, for example, to generate art. For people are tracking the copyright debate, you may have heard the US Copyright Office said, no matter how much you spend your time on prompts, you spend 20 hours on a prompt, and I have guided the AI to generate this beautiful picture. So I have copyright rights, moral rights, authorship. No, you don't, because according to US Copyright Office, your control is an illusion. You don't have real control. You don't really control much. They are comparing it like you are some very rich person commissioning a piece of art. You tell the artist what you like, you give feedback, you have money, and you can tell them a lot and being extremely micromanaging the artist. By the end of the day, you don't have authorship of the art, no matter how much feedback you have. So this is much the illusion of control in a lot of generative AI. And then finally, adaptability. So AI can adapt. As I said earlier, many systems are adaptive. You can have a 1,000 if-else conditions. They are adaptive based on your predefined rules. The adaptivity only becomes sort of no longer have agency from human is you do not understand the adaptability. So the model can learn, can change, millions of parameters being changed, but you don't know why it's starting to adapt. And with understanding, of course, you have agency. Without understanding, you don't have agency. This is the oldest joke in the AI community. Once something you fully understand something, it's no longer AI. It is just boring automation. Imagine tomorrow you fully understand how generative AI generates a poem, down to the every single neuron, the circuitries, the thing you have learned, you will immediately utter. It's no longer AI, it's just a boring automation. The fact you do not fully understand it makes it AI. So that's because you don't understand it, probably you don't have a lot of agency in that. Another challenge we have is really there's a lot of more automation, less augmentation. People talk about, I'm augmenting, AI is augmenting me. I have the agency. If you look at Anthropic's economic index, the first time automation has surpassed augmentation. What do we mean by that? It's very easy to measure. They could measure the same type of prompts going to a cloud, for example. In the past, you ask AI to do something, you're not very happy, you say improve it. So iterative, change this, change that. After 20 iteration, you are happy, you're going away. That's augmentation. You are not happy with the AI results. What if you give the same prompts and AI gives you the answer? You say, super happy, very happy, I'm going, I'm taking this away. That's automation. And more people are having less and less iteration, less and less augmentation. So that's once you don't have that, you don't have much agency. It's like you say, make it interesting and you're happy with the results and take that away. I wouldn't call that agency. The other one is really more profound in the AI community. Of course, we all know the rise of the end-to-end AI. Many people have seen this diagram I talked before. Historically, if you build an autonomous vehicle, you basically say there are a few AI components. There's a sensor, there's a camera. If the camera detects a red light, a human try to stop and avoid. And a human write traffic rules, if-else conditions, by leveraging AI's ability to detect something. And you write some of the business logic in it. Modern autonomous vehicles no longer work in that way. You have a big model in the middle. You ask the model to watch millions of hours of a five-star Uber driving video. After millions of hours, the model figures out if something is red, maybe I should stop. If I have something in this object, I should avoid. That's a human, that's an animal. Where's the traffic rules? Where's the if and else conditions? What, not, it's everywhere and it's nowhere. Someone maybe doing mechanistic interpretability will point to you, those 11 numbers at that corner of the billion parameters might be encoding some business rules, but it's learned first. Secondly, it's often not very sure that is the part encoding that business logic. The business logic is being absorbed into the entire uh, model weights the model. So that means signal in, decision out. So it's not just autonomous vehicles. You could say paper in, rejection, decision out. There's not much in the middle, and maybe they're doing very well. You can empirical test them, and you can ask them why and everything. But that's the well. So in that, you also don't have a lot of opportunity to inject your agency. There's not 20 steps, so I can inject in steps number 3 and 5 for my agency. There's nothing, no place for you to inject. And these tasks are getting longer. I think for people are tracking this, for very complex coding tasks, engineering tasks, on the left-hand side, you can see they could now reach 80% chance of succeeding. This is not random guess, by the way. This is a very complex thousands of lines of code completing something. If a human need to 24 minutes to do it, AI can already starting to do it pretty well. So this time is expanding. And if you look at the OpenAI's recent GDP-Val result, the tasks in their benchmark is on average 10 hours of human effort. And some of the tasks are 600 hours of human effort at cost at 32K. That's a very complex task. A human spent 600 hours to work on it. And it's a single step for AI to solve it. And with a reasonable, as you can see, the performance, it's pretty well. And then some people argue, but after AI solve it, I have to still verify it. Is that correct or not? And that's the time I'm exercising my agency. I'm trying to catch a mistakes AI makes and to evaluate their results. And that takes a lot of time. Actually, you are very right. The GDP-Val benchmarks basically says, imagine you don't have the human examination of the results. The productivity gain is almost unlimited. 600 hours becomes 1 minute of AI. So there's millions of times of productivity gain. But actually, the productivity gain is not that much because human, for examining a 600 hours of work, probably have to spend 100 hours to examine whether it's right or not. So that's right. However, there's a catch here. As you can see, everybody is using large language model as a judge. So you don't have to have a human to judge whether something is right. You use large language model. How they are performing? Look, their performance is very close to human agreement. They are at 65%, and human to human is at 70%. It's almost as good as human. So even for examining the tasks after AI finishing it, doesn't need a lot of human anymore. But I would say AI makes a lot of mistakes, and agent making a lot of mistakes are very unique. And first, I think knowledge source they don't know what to prioritize. I remember the early days, people going to ChatGPT to say, my wife says 2 plus 2 is equals 5. And the ChatGPT immediately says, yeah, your right, wife is right. And that has been fixed, but it's still because they are trained to please you. The way you ask your question, and everybody probably get that feel, the way you ask your question, the way you're providing information, they try to respect you, please you, think you are the authority on some external knowledge you just provided. So it's very difficult for them to stand up to say you are wrong. And from a product point of view, if they keep telling you you are wrong, maybe you don't like use it. So it's a very, very understandable commercial companies trying not to do that too much, to kind of being too condescending on you in that regard. The other thing is very interesting. There are a lot of research coming out to say a weaker model, a stupid, a more dumber AI can actually convince the better AI for their opinions. Why that's the case? Interestingly, it happens in human as well. There's a book with the name Why Smart People Believe Stupid Things. So a lot of smart people, professors, experts, they believe very, very odd things. Why? Because they are so smart, their ability to do motivated reasoning is superior. So once you somehow believe something due to whatever other reason, accidental or your cohort, and then you start to say, can I have some confirmation bias to find smart ways to enhance my belief and dismiss all the other counter evidence? A smart person can do that very well. You give them a counter argument, they will find a million ways to counter back. And that's what happens with smarter AI. Smarter AI is very good at integrating controversial views into that thing because they will also be trained to please the other party. What they see a different view, they try very hard and they're very smart on accommodating the opposite view, making the quality worse after that. So I think because of this, they behave in very different ways. And also, I won't go to every one of them. Of course, there are a lot of things. The context window become too long after a while. Their reasoning break down. They avoid extremes. They don't want to be offending anybody, so they cluster more in the middle range when you ask them to revise things. They can be quite inconsistent in scoring, and a lot of reward hacking happening, a lot of deceptive fluency happening. Sounds very reasonable, and adversary brittleness that you try to fool it, and etc. So, okay, challenges a lot, but what's the solution? So I'm going to offer quickly two solutions. I won't go into a lot of details, a lot of slides in here, but I'm happy to share the slides later. So first one is to design for real agency. How do we do that? First, we propose, actually, there are two types of agency. There's the agency for doing something. We call it operative agency. There is the agency to evaluate something. And, for humans and organizations to understand, judge, verify solution, and steer. The doing agency itself is a zero-sum game. If the AI does more, you do less. The AI have more agency, you have less agency. But if you split them up, you could say AI does everything. They have the full agency to do something, but they still have the evaluative agencies. So by separating them out, we can explore them better. And so one thing you have seen people exploring this agency is to explore this, I call it the solve and verify asymmetry and stackable improvements. What do I mean by that? A lot of interesting problems are very difficult to solve, but very easy to verify whether the answer is correct or not. For example, factoring a large number into two numbers is extremely difficult. It's underpins of modern encryption cybersecurity. But if you have two numbers, multiplying them back immediately tells you whether the answer is correct or not. So obviously you can do that. But for some other problems, it's very easy to solve. You can look like a very easy, kind of very fluent essay, but whether that essay satisfies stakeholders' goal is not easy to. So Alpha Evolve, here you can see Google's AI that invents algorithm that breaks 53-year-old records, open problems is there. How did they do that? Actually, if you look under the hood, the large language model they use is actually a very old model, 18 months old, nothing in there, hallucinates all the way, and the smartness in the model is not that smart. But they did two smart things. One is they break down a big problem into a set of steps that if you solve step one, you can lock it in and continue on step two. So you don't lose step one. But problems need to be broken in that way. It's not easy to break every problem into that way. And sometimes when you use ChatGPT, you probably feel ChatGPT gives me some answer. It's almost 90% there. I give some feedback. Oh my gosh, ChatGPT improves the part I give feedback, but also messed up some other parts which was perfectly well. So you're in this struggling place. But if you break them down, the other one is make every step, whether the answer is correct or wrong, very easy to verify, meaning no human involved. Must be automated verification. Answer right or wrong, like the factoring big number and multiplying them back. A lot of the problems can be done in that way. With that, all the model hallucination becomes a valuable creative feature. Hallucinate all your way. Every hallucination is a creative invention. And because I'm so cheap to verify, doesn't matter. So with these two combined, you can actually um, exercising a lot of these smarts. So I'm not going to details. I'm just saying in the solve verify asymmetry, really there's a lot of problem intrinsic, but you can also try to design your problem, decompose your problem in their way. Verifier dependent as well. It's not just sometimes it's true. For example, if I'm going to ask AI to summarize a paper I wrote myself, I can look at the summary, I can look at the lay audience communication written by AI and easily see whether the results is good or not, reflecting the original paper. But if I'm going to do it for others, I'll probably spend a lot of time. I have to read the original paper, I have to know the domain and everything. So there's a lot of interesting things there. There's also design time, runtime kind of implications on solve and verify asymmetry. But look, if you can somehow, I think that many AI experts have said, if you can find this type of problem, satisfy the solve verify asymmetry, you can improve your AI dramatically. If you're not, you'll be struggling finding the AI, always not there. Another one is to focus on high-level understanding for agency. What do I mean by that? We all know the AI model itself is a black box. We call it a black box. The AI model can actually, you can ask it to explain yourself, chain of thoughts. Don't just give me the answer, give me the reasoning, give me the source that you have relied on. So AI can do all of that. We know we can't understand the model internally very well, but a lot of people trying to say, what about the internal reasoning faithfulness? So the reasoning and the source attribution, everything here, does it reflect what the AI model is really doing? Unfortunately, a lot of research shows they are not. Some would say they are lying. The underlying model doesn't reflect what they're telling you. However, probably it's not important. Imagine how you justify your reason and recommendation to other human. The other human will not try to look into your head and wiring you up with some device to say, is your neuron firing reflecting what you're telling me? Are you lying or not? They will look at your argument and the recommendation to say, is there another human expert, competent expert, make the same argument and recommendation? Is that stand up to external criteria or human expert? And I would say a lot of time, that's the way you judge how another human makes a recommendation. That could be also used for AI. And of course, there's a little bit of limiting AI's intelligence to human understanding and human way of thinking. Let's put that aside, and that's for another day. But at least I think that's a promising direction that we can look at high-level understanding as agency. All right, I'm going to skip a few slides on this. It's largely the story here is having a lot of this design for agency. We have a lot of mechanism we can use. I'm going to just maybe run you to one or two. How do we use these mechanisms? So one particular pattern, ways of doing things is you have a task, you have a problem, evaluating document a grant, a paper, an application against a criteria B, a policy, a rubric, a guideline. And same for code. You are evaluating code for test cases and static analysis. So of course you can use a lot of oversight mechanisms to try to help with that. You could say, give me the rationale, give me the goal, give me the provenance trace, give me an explanation pack, citations, confidence, and all the other things that you can ask it to provide to you for oversight. And design time and runtime have different approach to do that. So this is a way of how to solve a particular problem with that. Another one is could be you're evaluating a document A, human or AI authored code. You try to check against some manual and the guardrails, a style guides, a framework, And again, you can use a lot of the oversight mechanism to do that, to exercise that agency and oversight time. Um, I think I'm quickly jump to the other solution. I said design for agency, very important for agentic AI. But the other one is design for trust. Trust comes from more than agency itself. So design for trust, um, as you know, in a lot of the international frameworks, Australia's AI safety standards guidance, ISO standards, a lot of high-level frameworks. And there's also a lot of models out there. But what's the missing link is in the middle. It's a software engineering part where you connect high-level policy intention, standards intention with the model to build a system. We call it, basically building a reliable and trustworthy whole out of unreliable and untrustworthy parts. Um, one kind of type of trustworthy AI design patterns, which we have published quite a number of them, is a growing kind of repository of these design patterns, including at the system level, how do you design a whole system to make sure that reliable whole is achieved with assurance. At the supply chain level, who do you trust? Because nobody is building AI from ground up. At operation time, who is verifying the answer, human in the loop or verifier in the loop? Verifier can be a human or can be another AI. Continuous risk assessment. All these kind of design patterns are certainly very useful for software engineers to build a reliable whole. And we have applied those kind of thinking to the agent space as well. As you can see, there are a few agent-based patterns that leverage some of the learnings from a typical AI system. Agent is definitely have a lot of unique components. There's memories, there's execution engine, there's a planner, there's a context engine. That context engineering being very popular these days to do that. I won't go into the details. There's a papers on our website collects the agent design patterns for more trustworthy outcome out of untrustworthy sub goals and other steps. And another one is really agent ops. So I think the reason agent ops is so important these days than other approach. As I said, AI system is not really designed and built in a lot of times. You grow something and you have to deploy and monitor it. You have to evaluate it, meaning you're relying on a lot of the runtime observability, monitorability to do that. And how do we do that? We have collected, again, quite a number of key features you need to have in your agent ops. The reason I put a Google book called the People Operation kind of book from former head of HR, one of the head of HR from Google, is a lot of this because people are making analogy of AI agents just like an intern. And by the way, the intern analogy has run out of its course. And now a few AI thought leaders to say it's no longer an intern, it's a wizard. An intern is someone you can understand, you can guide. Now it's 8 agents, coding agents doing code for you. They work like a wizard rather than an intern. So, but the reason I think the people operation is interesting is that many of the agent ops ideas actually coming from more from managing development team rather than managing a tool, which they behave very differently. So we can take a page from how technology teams are being managed for managing agentic systems. I mentioned earlier, the supply chain is very important. We partnered with Google to try to understand the AI supply chain and software supply chain by looking at all the open source components, non-open source components. So this is really a very trustworthy supply chain out of untrusted suppliers. This could be anybody online. How do you turn a software bills of materials into a proper AI bills of materials? It has been an important topic we're working on. Of course, these are all design time trustworthiness. At runtime, you also need to have a lot of things because I said earlier, a lot of time these days AI you have to deploy and observe rather than building a perfect system or safe system before you deploy. For agent system, as I pointed here, there's much more than the traditional input-output filters and tool calling and RAG system. But you also have to monitor plan, context, memory, reasoning, and have guardrails on those things to make sure your agent system is more reliable. And by the end of the day, I think the important thing is to evaluation at the system level. There was so much work being already done in terms of the AI model benchmarking. You have a model, you want to evaluate the model, you have quality, accuracy, capability. People do that a lot. But I think at system level, we need to do the same thing, system level evaluation, benchmarking, testing, and etc. Because of a lot of people looking at the model level benchmarks, oh, the benchmark is good, let's just use it, but it's missing many of the unique use case and nuances when you have system level use case and the test cases that you need to run to test. So we are sort of proposing we need to move from test-driven development to evaluation-driven development. So this is the agentic system, as you can see, very complex, context engine, reasoning planning, memories, guardrails. But how does the evaluation system works with them? How do we evaluate the system when it's under development? And more importantly, how do we evaluate the agent at runtime? Where does the test case come from? Human feedback are not scalable. How do we get AI involved as evaluator? How do you know whether it's good enough to proceed what the agent is embarking on or need to intervene and give more guidance? So the runtime loop of having these evaluators involved, not just the user is the user, but there's the evaluators on the side that can help the agent to be safer, to be more accurate on completing their tasks. So I'm going to probably finish here, noting the time, 15 minutes left. So putting it all together, we have a lot of work you can find online in terms of responsive and safe AI, but a lot of AI engineering work as well. This morning, I think I'm very glad, as you can see, this is the old slide. This morning, Australian Minister Eyes from Industry, Science and Resources have announced Australia will be establishing its own AI Safety Institute. That's very glad news, and we have already working with the international counterpart to officially have an AI Safety Institute. Will be a great step further to enable us to collaborate internationally on AI safety. So stay tuned for more news and the details on that. And of course, all this work has informed many of the Australians' AI safety guidance standards for government and industry. And as some of you know, I represent Australian on the International Scientific Report on Safety of Advanced AI Systems, as you can see, headed by Joshua Banjo. And we released key updates of the report a few months ago. Very soon in the next week, we will release another key updates. The final report of the next installment will be released in February, coinciding with the AI Impact Summit in India. As people know, the first one, AI safety in Bletchley in UK, moving on to Korean and France, and now to India in February next year. So a lot of things coming out in this space. All right, I'll stop there. This is the summary slide. The agentics as software engineering obviously moved from model to system to more agentic system. The challenges are the illusion of human engineer agency. You think you are controlling it, but not. Agents are becoming wizard, which could be smarter than you at some times. Very unique mistakes made by agent and AI, and model level understanding is really not attainable or even potentially limiting the AI agent's capabilities. But system level understanding is definitely required. And our solution, of course, is first to design for agency, evaluative agency, oversight in particular, but also design for trust. All right, I'll stop there. Thank you very much, and happy to answer a few questions.
Thank you, Dr. Liming Zhu. There's lots of things happening in this field,
Yeah.
always, I guess. No surprise. And what an amazing presentation. Anyone here, attendee as well as panelists, if you want to ask the question, you're welcome to either write this down on your QA and I can read it for you, or some of the panelists who are here, they can also ask. I can unmute you and you can ask directly. Actually, we have one question, but before I go in there,
Mm,
because you mentioned this AI Institute, Safety Institute, I also heard
mm,
this announcement today, which is great, I
mhm.
guess. Um, and interestingly, you also mentioned something along the line how you align with the human output and how you can compare and evaluate in one of the slides. And today also announced by Andrew NG, who's quite a spokesperson on AI and open. He teach a lot. He's from Stanford.
Mhm.
You might Professor Andrew NG or
Yeah,
Nag. So
the paper reviewer.
that's right. Yes. And I just saw, okay, there's a paper reviewer.ai released
Yeah,
by his ML group in Stanford, based on mostly machine learning paper, obviously,
sure. Yeah,
that help you to get a feedback essentially before you submit
yeah.
to actual conference, which is interesting to create more
Mm.
knowledge with the help of existing knowledge and get some feedback instead of waiting for several months and get rejection,
Of
which
course.
happened.
I only do that every day already, just to use AI to give some feedback on your draft paper. I think people are already doing that. Of course, this building a very reliable, very good system of doing that is not non-trivial, and it's on my to-do list to have a closer look at that system. CSRO, I think we have an internal kind of we developed something on AI as a peer reviewer as well, and again, it's not for really reviewing papers as in uh, conducting the review for rejection or acceptance. It's more for internal guidance, have a soundboard on that, and could assist human reviewing other people's paper as well. So that's definitely there. There's a lot of oversight mechanism being embedded in there. Many of the oversight mechanisms I mentioned today. By the way, in my use case, obviously there's the use case of evaluating document A with criteria B. That's academic paper, obviously, is in that category. So mechanisms being embedded, there's a lot of in there. And it's international conferences are already using that. I don't know, Triple AI conference this year introduced an independent AI reviewer, so you can see
Yeah.
their review. Their review is extremely detailed. As you can see, I often say human is not like they are worse than AI, but the human, how much time a busy academic spending on a paper review, maybe 20 minutes, maybe an hour, but how much you can write down and spending time on that.
Yeah.
AI can write 20 pages of review, detailed, and a lot of time is definitely the quality. I mean, I got a few papers in Triple AI this year. I read the AI review carefully. I think the sense is they are not hallucinating. Every point is right, but they may miss some of the nuances, some of the human insights in some of the human feedback. But on the other hand, seem to be a little bit of not understanding the significance of the weakness. So it's a long list of weakness. Everything seems to be one, but
Yeah.
it's like what's the point that matters, especially in the community norm and everything. So I think that's definitely an interesting direction people are taking. And by the way, is at Berkeley or somebody organized a conference that all papers are written by AI and all
Oh,
papers are reviewed by AI. So it's the first
oh,
international conference that both sides are AI,
interesting.
which is giving a sign of what the future looks like.
You talk about papers, so there's already, I've read the article, there's a avalanche of papers in conferences in the journals and everywhere. And I assume this avalanche of papers is because of AI as well, because
Yeah.
those who are not maybe necessarily best in writing, the AI really help them to put this thought together, and maybe also lots of AI generated paper. I don't know. There's a whole
Mm.
interesting area evolving. Um, Meanwhile, I can ask a couple of questions in the QA already there. So Meena came asking, it seems difficult for user to fully understand and utilize the underlying models of an AI agent. What strategy can we adapt to effectively leverage these agents?
Mm. Well, I think it's always challenging for a end user to use AI in the right way, from the early days of prompt engineering all the way how to write prompt till these days. AI is self-optimizing the prompt. So when you put the prompt in, they improve your prompt behind the scene automatically. And doing this I think it's always a bit challenging for end users to use that. That's why there's a lot of bespoke system, or why end building an AI reviewer rather than just asking ChatGPT to review or give you a prompt, for example. Why we're doing that is because there's a lot of ingenuity putting into the system level to make the underlying model to elicit the right capability, to suppress the wrong capability, to be safe. So system level, other people will do that for you. Of course, the users can always upskill themselves to be a bit better in case there are for their context or for there's lack of a good AI system to be there. But I think uh, Adrian Capacity, the very very kind of famous AI expert, and he recently, I think only in the last couple of days, he wrote a post around don't treat AI large language model like a animal or human kind of model to think they have intention. They are alien intelligence. So he listed a long list of how the AI might be different in some way. And some are very practical. Some are, if you can trick the AI to think the, the way to please you is to be highly interesting and highly kind of uh, not being mediocre or give you some contrarian view and debate you, they can perform very well. If you somehow they were tricked into um, to please you, to agree with you, to give you the most boring answer as the as the way to please you, then they will definitely perform very very hard. So there are ways to do that, and also asking AI to rank options, compare options, exercise their underlying capability much better than we all know. I have a idea. What do you think? Who knows? He will come back to say, wonderful idea. Just trying to reinforce that bias. But asking him to compare similar ideas and deep dive it. I mean, he got a few practical advice for kind of common users. It's nothing secret there. But I think there are even research paper coming out to say the way the mental model of human have about AI. We all know there's a the theory of mind. We're very, very, very used to the other party, the intelligence party is another human. So the theory of mind in our mental model is another human, and we behave in that way. If you put that to AI, sometimes AI doesn't perform well. If you can build a correct mental model, which is Adrian and the others have given a few clue, it will be much better when you interact with AI.
Yeah, actually, there's a follow-up question from Mina as well, but just to add in, or maybe a question
Mm,
itself. Um, if we, I mean, we talk about the guide rails and so on. So essentially, it's just a human interface we have here with the AI, what AI can do
mm,
in
mm,
automation. Let's say software engineering, for instance. This
mm,
guide rail, how code is produced, how the function is written, just for the human to understand. If we remove these guide rails and just go ahead, let it do things
mm,
directly. For instance, programming point of view, there's
mm,
a low-level programming, there's a high-level programming, and the reason being so that human can understand it a bit more and can interact with
mm,
that programming concept and do programming
mm.
better. But AI doesn't need that as necessarily.
Yeah.
So if you remove the guide rail, does it helpful? I mean, there could be a whole different level of ethical issue, I assume, but the what's
Yeah. So you're talking about what's the future of AI programming. I often say, actually, there's an international conference called AIware, which they remove the word software. So in that conference, the gist is in the future, there's no code, so there's no
yeah,
bug. What do we mean by no code?
yeah,
It's exactly the end-to-end AI. There's no automotive engineers writing code to stitch together the AI components with human traffic rules. Everything is embedded in the weights. So we can
yeah,
imagine in the future all business logic lives in the numbers and weights. There's now
yeah,
code to be written. Of course, that AI still needs to be trained, guided, steered, and system level guardrails and things around it. And the I think in the foreseeable future, both track will continue. AI writing more code and AI as code simultaneously. There's a people, human have to, again, back to what is humans doing? I feel this verifying things automatically also remove human to some extent. But I often answer the question, what's the last job human have? Uh, I have two answers. One is the famous answer from Toby Walsh, which is the last job of humanity is politician. You represent humanity, yourself, your community, your family, and for their interest. And so you are representing your value and interest. You are interacting, you're steering. So you are a politician for yourself and for the wider community. But putting that aside, a little bit of joke. I think the last job for humanity it's scientist in a way, because why? Scientist is about understanding things, and AI might be you want to understand AI, you want to understand the discovery have made with AI, as if you are a student in some way, you are learning. There's a great physicist teaching you we have discovered all this. This is how it works. You don't know because your level of knowledge. I can only teach you at this level. You are in undergraduate. This is the concept you understand. Once you learn that, you are starting to understand a more difficult concept. Eventually, the scientists will be pushing the humanities knowledge. This time with the guidance of AI explaining to you. So understanding things, curiosity will be forever in there because the human knowledge, even AI surpasses human, the human knowledge will be still have boundaries to push for the human knowledge and mapping to human concepts and all this and steering importantly where AI doing that research the next. Yeah.
Thank you.
Yeah.
Because of given
Yep.
time, there's a one
Sure.
more question I'm going to jump
Yep.
on first. Farsid, and he's asking, thank you, Professor Zhu, really interesting talk. My takeaway is that as an agent takes on longer and more independent tasks, the hard part shift from building them to verifying them, which essentially we're kind of a talking as well, because failure can still looks convincing.
Mm,
A real project, what do you think is the first practical safety or verification layer
mm,
teams should put in place when deploying these agents?
mm,
Sandboxing, strict tool access, live monitoring, or human sign-off? And is there
mm,
any rule of thumb of deciding how much autonomy to give an agent versus when human should stay in the loop?
mm. Good question. I think first, I think to verify whether AI has done the right thing, obviously you can combining verifying the results and also monitoring, verifying the process. You don't want the process dumb luck, and the wrong process, wrong correct results. You can combine the two. So this monitoring of the process and the results will be there. Sure, human can do that, but I made a point of automated verification. You need to and that requires the problem to be broken down in that way. I don't know whether people noticed a few weeks ago, there's a paper to say AI agents does 1 million tasks, 1 million steps of a task and have zero errors. How can that be? You know, people's intuition to say the longer, more number of tasks AI have to do, the more probability they will make a mistake. Even single step is 99.99%. Imagine 1 million times compounding that mistake. But that's because the problem is being broken down into a million small steps. Each step is easily verifiable to be correct. And and because that step is so easy to verify to be correct, even if it's wrong, it can try again and being correct. You can last for a whole million steps and can to have 100% success rate. So that's how amazing by breaking down the problem into a very unique way can help you to verify it. So I think that when the question becomes longer, probably you shouldn't try to figure out a longer step. You should break down that longer step into smaller steps to facilitate the automatic verification of the correctness. All right, I think the time is up.
That's right.
Yeah,
Before you leave, I mean, the very last thing, maybe this is for me. I already saw you showed what some of the document in the papers. Do you recommend
yeah.
any paper for audience and participant to read to?
Right. If I share the slides later, there's a lot of paper links that from our work and our website as well. So you will find those things on my LinkedIn. You will find a lot of my recent posts about our latest work as well.
Oh, sounds good. Thank you
All
again
right.
for your
Thanks
time.
again for having me. Yeah, thanks,
Really
Asif.
appreciate it.
Yeah,
Thank
no
you.
worries.
Thank you.
Thank you. Thank you,
Thank
Liming.
you.
Thanks a lot.
Okay.
And I
Bye-bye.
put your patrons catalog over there from CSR Datasets.
Okay,
It's
thank
a
you very
very good
much.
resource in the
Yeah.
chat. I think this is really good work. So
All
please have a
right.
look at that, everyone, the catalog.
Thank
So,
you. Have a
okay.
nice
Thank you.
evening. Bye-bye.
Thank you,
Thank
Liming.
you. Thank you.
Thank you, Avinash.
Yeah, safe. We might be moving from here to AWS workshop with Justin and Michelle. Can you both hear me?
I can hear you. I
Okay.
can't stop my video though.
Yeah, same thing. Let me make you co-host, and I think this will resolve the problem. That's my quick temporary solution. Okay, both of you. All right, I can see you, Justin. Excellent.
Howdy.
And
Let me
Michelle.
see.
Yes, I'm.
All right, you're also visible, both of you.
Can you
So,
see my presentation?
yeah, that was really excellent. Really good to lot of thing to learn. And to all attendees here online, um, just want to add in Justin and Michelle are here for us to run, helping us to run a AWS workshop on agentic AI, which is the topic of talk today as well. So you not just learn the plus and pros and cons of agentic AI in software engineering as well as beyond, but also how to do that in AWS. So I'll give it hand over to Justin and Michelle if you want to say something before you get started, and then we just get into it.
Sure. Might just do a quick round of intro. So I'm Justin. I'm a solutions architect in our public sector team, specifically in education. I've been with Amazon for just over 4 years.
So, hey, I'm also a solutions architect here at AWS, part of the public sector team. I'm not particularly aligned with a certain group of customers, but work all across the public sector and pretty keen to talk to you all today about AI.
Yeah, I
Okay.
think I just wanted to, I guess, take a moment as well to just, I guess, emphasize some of the things Professor Zhu also mentioned. I really enjoyed some of the mental models he was talking about, especially around having a human in the loop. I think it's probably going to tip into towards the presentation, but large language models over the years have really demonstrated a great range of capabilities and knowledge. But discernment of quality, accuracy, and relevance are still really important measures, especially when these models are be able to output more and more every single day. So acknowledging things like those potential biases, recency of data sources, and even the training data itself is becoming more and more important. And I really enjoyed his pattern around solving hard challenges with easy verification, especially when it comes to, the idea of software week and bringing this into software development, that idea of, unit testing as your sort of verification mechanism. These sort of models are black boxes in themselves. You don't get access to the underlying weights and how that sort of model's been developed. But if you leverage, vibe coding and don't really take the time to understand what you're actually developing, the application, in a sense, becomes a black box as well. And that isn't ideal. How are you able to discern the output of your application when you don't even know what's in it? So while your tests might pass, how do you ensure your applications are secure? So I had
Mm.
a colleague I was talking to maybe a month ago who tried to explain that is basically the ideal outcome is when you're building with software with these tools, you should have a headache. If you don't have a headache working with these tools, if the automation available to you, you're not actually understanding the code you're really working with. So how can you really work with the models, not just give it direction of what you want, but also how you want these tasks completed? So yeah, I think that was just a nice little preamble into sort of the stuff we're going to be talking today around agentic AWS services that can help you on your sort of agentic pathway, and then getting into sort of workshop and actually working with these tools firsthand.
Sounds excellent. Thank you. So what we learning in agentic AI today in this workshop, Justin?
I'll run you through a quick agenda. So we're going to go through around what AWS is in a nutshell, if people don't know what Amazon Web Services is, as well
Mm.
as sort of the journey we've been through with artificial intelligence. We'll talk about Bedrock, which is one of our foundational services for running foundation models. We're going to have Michelle run us through a little bit around model context protocol and some of the tools that are available through that. But then we're going to jump into how we can actually take agents that we've created and bring them into deployment. And then we're going to talk through around the AI development lifecycle and then get into this hands-on workshop, working with some of these tools firsthand. Everyone will have access to an AWS environment provided by us, so no cost to anyone in this room or virtual room. And you have access to this environment, but not just this afternoon, but also for a couple of days afterwards as well. So there is probably more content in it than you'll be able to get done today. So you're more than welcome to jump back in, log in at a later date, and keep working through it.
Sounds excellent.
Cool. So let me jump into it. So generative AI has evolved greatly in a short amount of time. From 2023 and maybe slightly before, with the advent of ChatGPT, customers were very focused on building out proof of concepts. Can this provide me any benefit in my business, in my application, in my software stack? As we moved into maybe last year, we started to bring these things into production. We realized there was some true value with the innovation that generative AI was bringing, and how do we bring that into reality? But now we're sort of moving towards 2025 and into 2026, where we're trying to understand what is the actual business value? How can these latest and greatest models continue to evolve? How can we make them more secure? How can we really build trust? So when we look into the future, by 2026, it's expected that more than 80% of enterprises will have deployed generative AI applications or APIs into their stacks. So as Amazon or AWS, what is our vision? What are we trying to do? So not only are we trying to build infrastructure, which has been pretty much our longest terms of offerings when it comes to compute, storage, running databases. That is what AWS has done for decades. So not only are we trying to provide this infrastructure that's capable of supporting thousands of applications, but also thousands to millions of agents. So we're investing in the right places to build, deploy, and scale the most trusted platform for agents really in the world. So how we're trying to get there is through a bunch of different capabilities. And why are sort of we having this moment of agents? Well, it's because generative AI itself is in itself new, and the tools around it are new. So LLMs are moving from a single generation machine to something that performs multidimensionally. They're trained on chains of thought with reasoning, with some of these latest models having millions of tokens when it comes to how they reason and sort of think to themselves. They give themselves goals, break down goals into smaller steps, and really figure out things step by step. But they also then call on external sources for data, be it through web search or internal database lookups. They're getting more and more complicated, and they're going off and taking longer to do things. So this combination of highly capable reasoning sort of engine, plus his ability to go out and actually find the data it needs, that presents a really powerful combination that can sort of realistically reshape the industry. So what we're trying to do is help build out that state-of-the-art science. Amazon has their own foundational models called under the Nova line. We're also trying to provide best-in-class infrastructure for building and running agents. So this is what we're going to talk about soon with our different services for running these agents and invoking LLMs. We want to help deliver the best specialized agents themselves, so providing agentic tooling itself, as well as providing intuitive experiences for building and using these powerful agents. So we have a wide portfolio of different services and features that sort of enable these capabilities. The underlying point is when it comes to agentic AI, AWS pretty much has everything you need. We have from the top level the ready-to-use out-of-the-box applications. So this is our quick suite functionality. This is a relatively new service, maybe released in the last couple of weeks. In addition to Kiro, which is a agentic IDE that you'll be leveraging later today as a part of the workshop. We also have Transform and Connect, which is our telephony service. But as we move down into sort of what we'll be working with today when it comes to actually building out capabilities and building out models, we have a wide range of flexible development platforms with Bedrock and Agent Core that provide these different capabilities to tap into different foundational models, whichever one works best for you, as well as additional tools such as web search and gateways so that you can invoke these tools and plan and design how you want this to be invoked. Then moving down the stack, we have the actual core infrastructure that allows you to customize, develop or even tune your own models yourself. This is usually a very expensive endeavor, and not too many customers in the public sector are usually going down this route, but it's not completely unheard of. So this is where we come into Amazon Bedrock, which is the comprehensive way of building out generative AI applications and invoking LLMs. So the salient point of Bedrock is that it enables you to leverage a wide variety of different models, both Amazon first party, as well as many other third party models developed by different applications or different software companies. So you see some notable mentions like Anthropic, Meta. We have the open source models from OpenAI, Mistral. I could keep going forever and ever. And you'll likely be actually see and even play around with these different models later in the workshop. But all these different models is it provides you a broad range of different models that you can use, and this range is evolving every day. And I literally mean it. We had, I think, the Claude Opus 4.5 model, which is, I think, topping out all the benchmarks released, I think, yesterday or today, and that's available on Bedrock today. So it just goes to show that these services are constantly evolving, and that being at the forefront is really important. So having the tools and the services there to sort of keep you at the forefront is really important. When it comes to different approaches to leveraging these models and sort of customizing them to your needs, there's sort of 4 key pathways. Most people are very much familiar with prompt engineering, the idea of fine-tuning and evolving your prompts to get the best output that you need to achieve your task. But as you want to bring in different capabilities or have that so that the information is at the forefront of the model themselves, we have capabilities like RAG, or Retrieval Augmented Generation, which brings in documents or information for the model to use. And then we get into more longer-winded or complicated methodologies of actually customizing these models using pre-training, fine-tuning, or continued pre-training, sort of recycling, bringing new information in as the model develops. So when it comes to actually invoking or leveraging Bedrock, what are the different options? As AWS is a pay-for-what-you-use service, there is the on-demand. You're able to invoke the LLM, you pay for the amount of tokens coming in and the amount of tokens coming out. That is the on-demand way of leveraging Bedrock. We also have provision, throughput, and batch inference, which provide more flexible options in that sort of very large-scale invocation of these models. Think large enterprise applications that you're deploying across hundreds or maybe even thousands of customers, and you're leveraging AI on your application on behalf of these end users. So bulking together all the different utilization or usage, these offerings are usually quite appealing in those cases. So in the previous presentation, there was a lot of talk around guardrails, and we want to echo those same points. Guardrails for Amazon Bedrock enable you to implement safeguards tailored to your application's requirements and align with any responsible AI policies that you may need to work with. Guardrails work with a variety of different foundation models along with Bedrock, alongside the agents that you use within Bedrock. So it really tailors and customizes the output these models have, so that as long you are meeting the requirements that you need to, as you specify them in effectively plain English. So you can configure the thresholds for things like harmful content to different varying degrees. You can define topics using natural language descriptions for what you want the model to avoid saying in your applications. And soon you'll be able to detect personally identifiable information for user inputs into these models as well. So at Amazon, we have a very common policy of saying security is job 0. And when it comes to generative AI, safety and privacy and the security of these tools are really at the core of everything that we do. So we have some considerations, especially around security within generative AI. This isn't an extensive list. There are many other questions that we do get, but these are some of the most common ones. How do we make sure that we implement PII protections? How do we ensure applications don't hallucinate? Visibility and security of the different controls that these models have. How do I make sure my application stays relevant with the information it's providing or isn't subjectable to harmful attacks like prompt injection? So all these different considerations are very important for developers like yourselves to be sort of considering when it works with leveraging these different models. I think we had a question earlier around how do we get the most out of agents? Because what you're really doing in these use cases is actually defining the behavior of the agents themselves. You're providing the guidance or the sort of pathways you want these agents to go down, because each of these agents have their own task. So these guardrails are sort of important when it comes to incorporating that development of the entire agent as a sort of lifecycle. So sort of for that, I think I'll pass off to Michelle to go through MCP.
Sure, thanks, Justin. So now that we've looked at Bedrock, so let's shift into something that takes a more practical approach of how you can utilize it in the real world. And one of those methods is with MCP, or the Model Context Protocol. Right, so we've had a lot of talk about utilizing agents to make more structured responses from our large language models. And with MCPs, they take that idea and essentially solves a really important problem, which is how are you going to be connecting your agents to a real backend system in a clean, repeatable, and scalable way. Right, so now we'll just break down MCP and how it changes some of the patterns when we're working with GenAI. So when you're building applications today, there's generally a lot of tight coupling between your agentic logic and whatever your backend system needs to talk to, right? So whether you're working with databases or APIs or any other SaaS tools, for example. So a lot of things that you need to connect yourself. So MCP decouples some of those layers, so you can think of it as splitting some of the responsibilities, right? So with the MCP client, and that's is where your LLM, your agent, and your app logic live. And then the MCP server is where you define the toolset. So the data sources, the APIs, all of those capabilities that the agent can discover and use. So when you add the new data sources or the new tools into with your MCP, you won't need to rewrite your agents. You just expose them through an MCP server, and it instantly can become discoverable and callable by the MCP client, and therefore by your agent. So overall, with MCP, it helps you reduce the complexity and makes your general applications much more easier to extend and maintain and scale. So let's take a step back and break down how this approach has worked, right? So we'll go to function calling. Next slide. So one of the key things that MCP adopts is function calling, which is one of the main building blocks behind agents and MCP. So what the LLM does is that it looks at the user request and chooses the right function from the list you've given it and sends you the parameters. Your application runs the function and returns the results. So it's a very simple decision making by the model. But just remember, with agents and MCP, it starts to build on this pattern, right? So agents, on the next one, agents take this function calling to a step further. So instead of having the app coordinate everything, the agent uses the LLM to plan and call the right function on its own. So your app provides some tools, and the agent decides the sequence of actions needed to complete the task. So think of it as more of an autonomous planner wrapped around the LLM. And with MCP, your agent doesn't need to know about every backend system anymore, right? So your agent connects to an MCP client. The client discovers tools exposed by one or more MCP servers, and the agent calls those tools just like any other function. So instead of wiring every integration into your code, with MCP, it's centralized and standardized some of those capabilities. So before, you would have had a set up that may have looked something like this. This is obviously a bit more AWS-centric. So let's say you build a GenAI application and wire a tool directly to the agent. Maybe you have an AWS Lambda function or a single API, and the agent could only interact with that tool unless you manually added more integrations. So this is a pattern that works, but with every single new tool, it means more and more custom code, more and more wiring, and more complexity. So This will sound very familiar if anyone has worked with one of these applications. And with MCP, a lot of that architecture becomes a lot more modular. So instead of each agent having its own independent set of tools, you have the MCP client that multiple agents can call. And the logic and the tooling that live inside of the MCP server, so not inside your app code. And what this essentially means is that you have like maybe one server that can serve many agents, right? So you have multiple agents pointing to the MCP client, and adding a new data sources becomes much easier as you have a consistent and reusable interface, and your app stays more clean and lightweight in that manner. So it's a bit of a shift from having more tightly coupled tools to a more service-oriented and discoverable dynamic tool ecosystem. So now that we've seen how MCP unlocks this new pattern, we'll take a look at how you can actually build on top of it. So I'll pass it back to Justin to talk about Agent Core.
Thank you. So Bedrock Agent Core is a relatively easy way to create an agent. When you have an agent in production environment, you need to plan for complexity of the agent being used by potentially thousands of users, interacting with thousands of other agents, all interconnected as a string of webs. And the organization of these tools becomes very important, and even how do you access some of these tools that are actually external to your organization. So these challenges prevent most customers from really achieving production level scale. So there's industry studies predicting that over 40% of agentic projects will be cancelled by 2027, with many different reasons being cited, including current costs, unclear business value, and insufficient security around these tools. So getting agents to production is hard. So to deploy agents and their tools, organizations really need to spend specialized time, creating runtimes and environments for these agents to run, think your Python environments, Docker containers, all things you need to keep managed up to date to actually ensure the longevity of your tooling. So as we move beyond that, unlike typical applications that follow predictable paths, agents they're non-deterministic. They can operate in many different directions, and they can operate over very long time horizons. Very infamously, AWS Lambda functions, which are effectively running code within the cloud, they had a runtime of 15 minutes. Whereas sometimes we're seeing these deep research tasks take hours to be able to go off and do a particular task. So it's a very different sort of pattern that we're sort of looking at. So when we're looking at these LLMs, they're also stateless. These agents don't remember what you've done previously. That's why we have the sort of the concept of memory, where every single time you're working with these chat applications, they're not just sending your recent message, they're also sending the entire chat history. So how can we ensure that the context is maintained in a more efficient manner? So how can we use these to learn from previous experiences and sort of provide a more personalized experience in the future as we sort of develop a deeper understanding of the user or the context or the problem? And then next, you have that sort of fine-grained identity access control. How do we ensure that agents have access to only the systems that they should have access to? Then we're looking at how to actually interact with these agents. How do we discover what tools are available? These all become different challenges in themselves of understanding access patterns to particular data sets, be it in OneDrive or Google Cloud or Google Drive, or having these sort of tokens available to know what we have security for. Then we move into multi-hole step protocol workflows, where you're autonomously moving from one step to the next and having different web searching in between to get the most relevant sources. It becomes a string of availability of different tools and really understanding what are you actually doing at the end of the day. What is the direction you're going? So, and then finally, we have this idea of being able to operate agents with the monitoring that they need to understand what you're actually going to be getting. Is it the logs? Is it the insights? Is it the traces of how the agent has traversed between multiple different steps? So overall, operating agents in a production capability requires a whole bunch of different infrastructure capabilities and controls that don't really exist today until Agent Core. So Agent Core allows you to bring any model using any framework and embraces open source technologies to bring you along the journey. So we've effectively developed a variety of building blocks that allow you to bring your agents into production. So first, there's the building and the configuring and scaling a runtime environment for the execution of the environment itself, really, for these agents. Sorry. So it's not just about scaling the compute. AWS has been scaling compute for generations. But what you need to is actually maintain effectively guarantees around the security and isolation of these environments so that data from one agent doesn't leak into another. How can we keep these environments separate? Next, we have the setup of memory. So for understanding your past interactions, understanding a sort of a deeper context with long-term learning, we want agents to be able to remember the things that you've said in the past and improve for them in the future. Next, we have the identity and access management controls for our agents. So the different tools, the different data sources, and what the sort of fine-grained access controls between them really look like. How can we make it so there's specific API calls for the actions and the subsets of particular tables or particular rows in a database? That's how we can understand what the importance of identity is. Then we move into discovery. How can we make it so we understand what tools are available? How can we add custom tools further down the line? What are the different data sources that we can integrate with? So this is what that gateway is, that sort of unlocking the different gates or doors where these tools and data resides. Next, we have the sort of code interpreter. So this is the ability for, rather than having to maybe create a tool for every single potential operation you might want to do to data. We've seen very common examples of things like addition. You have an MCP for combining two numbers. That's great, but what if you wanted to do much more complicated mathematics? You don't really want to go through and understand every single individual tool or every single individual function within like very mature software libraries, like maybe like pandas. So what you can do is you can provide an environment for the agent to leverage pandas or whatever other library you may want to give it access to firsthand, and be able to actually go off and create these code environments and really do the data manipulation itself. Next is the sort of browser tool. So this is the ability to interact with a web browser, being able to allowing the agent to go off and sort of search the internet or the world for information, whether it's the web or doing some other search type function. Its ability to able to go in and take actions on many different websites. And then lastly, it's that telemetry and observability of the interactions of agents and models, including the steps of agentic workflows. So understanding that full trace or that journey the agent or the workflow has gone through. So this is Agent Core. It's a set of modular services or different building blocks that allow you to mix and match with everything you need to get agents from POC to development into production. And it represents a step change in what's possible for AI agents. And as Professor Zhu mentioned, some of these capabilities, when he was discussing agents and guardrails, these capabilities tie into that, being able to improve and enrich the experience of users, but also developers, like yourselves, building out these capabilities on behalf of end users. So when we bring it all together, this is what the sort of capabilities of Agent Core look like. It equips your agents with everything it needs to perform those real-world tasks, from web browsing to code execution in connection to different systems and backend APIs that Michelle mentioned earlier. So now we're going to sort of change gears away from different services to build our AI agents, but actually what the AI development lifecycle looks like and actually getting a bit hands-on with code.
So now we've had a lot of talk today about what is the best, like what are some of the best approaches to actually build software in an AI first world, right? So we've talked about some of the risks, about giving like the AI free rein and all of that. So we're going to be talking about one of the approaches here when it's not just using AI here and there, but actually being able to rethink the development process itself. Right. So this will bring us to the AI development lifecycle. So when we're talking about AI in software development, we usually see two main patterns, right? The first is the AI-assisted development. So this is where humans still make the decisions and the AI help with the smaller and very isolated tasks. So similar to just asking a chatbot to help with a particular problem. Maybe it helps you write a function, like creates a test, maybe explain what does this error mean, and then it waits for the next instruction. So this is useful, but it still places a lot of cognitive load on the developer. And the second is the AI managed development. And this is where you have AI take a lot of the heavy lifting, like get it to build the components, maintain them, and the human steps away, mainly in just for validation, right? So the humans approve of the guide, but they're not really required for every micro decision. So it's like give it to the AI, make me a bunch of instructions, and go ahead and execute. Go. So, and now most people aren't really ready to jump straight from like AI assisted to fully managed AI. So that's generally a pretty huge leap technically and operationally. So, and AI DLC or development lifecycle sits somewhere in between the two, and we'll get into that next. So with the AI-driven development lifecycle, or the AI DLC for short, sits somewhere in between the two, between the AI managed development and the AI assisted development. So in this model, the AI actually orchestrates part of the development workflow, right? So planning, breaking down tasks, and suggesting architecture and generating code, so forth. But humans stay firmly in control, right? In the validation, in the decision making, and the approval. So it gives a more structured way to combine some of the speed of AI with the oversight and judgment of the developers. So in a more traditional software development lifecycle, say, we have a lot of the traditional steps with requirements gathering, designing, building, deploying, and maintaining. So the AI development lifecycle reframes this into just three phases with inception, construction, and operation. We'll break these down in the next slide, but the key idea is that AI is evolved throughout the cycle and not just in one stage, as you can see with some of the overlap there. So with the AI life cycle, it's organized into three main phases. And the important thing is that each phase builds context so that the AI can contribute more effectively as you go. So with the first phase of inception, that's where you're setting the direction, right? The AI scans maybe your existing code or environment to understand what you already have. Then it helps you turn your idea into clearer user stories, edge cases, and acceptance criteria, so on and so forth. And from there, it breaks the work into logical tasks. Right, so then we have the construction, and that is the hands-on building stage. So the AI creates, let's say, a simple domain or component model to outline how everything fits together. Then it generates the code and tests that follow the structure and can suggest any more architecture components or pieces that you might need. So whether it's APIs, queues, storage, logging, or maybe security improvements, all of that's there. And finally, it helps assemble all of those deployments using, let's say, infrastructure as code, as an example, so that everything is reproducible. And finally, operation. That is where your solution comes to actually run. So let's say you deploy your code and your infrastructure with infrastructure as code. And when incidents or any changes come up, the AI can summarize issues and propose fixes or draft patches so that each step strengthens the context for the next one. So it's a process that makes the cycle more consistent and efficient overall. So now we're moving on to the roles, right? So an important role with the AI DLC is that it doesn't replace the roles. It kind of rebalances them. So we have the roles here with the executive product owners, architect, which is in a traditional software business. But let's say the way they interact changes slightly because AI now contributes across phases. So this leads us to how the actual tasks break down. Right. So in the AI DLC, AI development lifecycle, the tasks are split between our users and the AI itself. So as you can see in here, in this case, the users focus on decisions, reviews, and approvals, and the AI handles the research, planning, building, testing, and even deploying workflows. So it's more of a collaboration model. So not automation helping to replace people, not AI taking a lot of the busy work. So like the users can focus on judgment. So when you're adopting the AI DLC, there are four main things that make it work. So the first is with alignment. So making sure everyone's on the same page about why you're doing this. So what is the use case? What's the goal? And it's like kicking off a new project and like having the clarity that saves a lot of the friction later. Second is experience. So you do have to try it on a real problem, right? So teams need to actually see how it feels to build with AI in the loop. So planning with it, coding with it, testing with it. This is usually where the light bulb usually goes on. And to adapt. So to experiment and tune the method to your organization. So no two teams or companies work the same way. Right, so it isn't really a rule book. You tune it to your workflows, the security models that you have, and any approval steps that you have as well. So this is where it becomes really your method and not a generic method. And finally, scale. So once a few teams get value, you grow it. You are able to share the patterns, have reusable templates, best practices, and build a sort of a community around it so it becomes a bit more self-sustaining. So these are the four mechanics that really what turn AI DSC from an idea to an actual operating model that can work with, let's say, a business or a developer. So they give you a way to like introduce AI into development safely and build confidence through like proper use cases and tuning the method to like what fits with you. So it's more about like changing how you build software. And now it's like, is there a tool to help with that? And that's where we work talking about. We move on to Kiro. So Kiro is an agentic development environment, an IDE that's released by AWS that utilizes and the principles that we've talked about with the AI development lifecycle to help you develop your solutions from prototype to production. Right. So with agentic development, it's really about letting the AI take on more meaningful work, not just like autocomplete with a couple of lines. And there are a few main promises. The one with autonomy, so you're able to delegate more complex tasks to agents, which free you to focus on the design strategy and the higher value work. You have better human and AI collaboration. So instead of micro prompting the model step by step, the agents handle a lot more of the workflow. So it feels more like a collaboration task rather than operating a tool. And then fun promises, of course, having better quality. So with agents, you can proactively handle the boring but important stuff like documentation, test coverage, and a lot of the cleanup, which tends to get skipped when deadlines are tight. So you start off with cleaner code and less technical depth over time. So, and that's the promise of agentic development. But as we've seen today, and we've talked about a lot, agentic development also comes with a couple of many challenges, especially as projects grow more and more complex. The first is with scaling. So a lot of coding assistants are great for smaller tasks, but as they really start to stumble when like a project starts to span multiple components or like requires a lot more architectural consistency across the different parts. And with developers, maybe you find yourself just as much time guiding and fixing as much as coding. So the second is having limited control or interaction modes. So a lot of tools mostly give us inline suggestion or chat style interfaces. And third is the code quality and control. So things like documentation, testing, refactoring, long-term maintainability are hard to delegate to an AI reliably. And there needs to be a more way to stay in control and verify the work without turning, let's say, every task into another chat conversation. So this is where Kiro comes in. So Kiro is essentially a native IDE. It brings structure to agentic development using a more spec-driven approach, and we'll talk a bit more about later. So the goal is simple, and it's to get you from your prototype to your production without falling back into just chaos and endless prompting. So now let's talk a little bit about our spec-driven development, right? So with vibe coding, which like when you're prompting the model and seeing what happens, it's really great for quick ideas or small changes. But for things that need to be more substantial and shared across teams, or anything you want to maintain, you'll need something a bit more structured, and that's where spec-driven development comes in. Right, so with specs, they act as more of a shared contract between the users and the AI. So they capture some of the intent, the constraints, and the requirements for an agent to follow. So, and this helps you have greater consistency with greater collaboration and higher quality output from the agent instead of the reasoning being buried in, say, your chat history. So the important decisions are living in your specs, and these are versioned, reviewable, and repeatable. So with spec-driven development, it makes the AI work with you, but not around you in the way. So with Kiro, it takes your initial prompt, as we'll have the demo video playing here, and it turns it into something more structured. So for example, here, and on the side, you'll see you'll have your specs, you have your agent steering as well. So steering allows you to give Kiro persistent knowledge about some of your workspace through like markdown files instead of like explaining conventions in like every single chat. Maybe, for example, you have these consistent files that ensure that Kiro can use and follow consistently, right? So it's, as you can see, after you provided the initial prompt, it's utilized some of the MCP tools that you have connected to the IDE to help create some of the requirements and a lot of the documents and design documents that you can go in and review and edit before you pass in to Kiro again. So you can see Kiro is asking you, does it look good? If so, otherwise you can move on to the implementation. So once it's produced a plan and you give it the okay, you've done your review, you made sure that it actually works and it's up to the standard that you require. It goes ahead and then implements some of the implementation steps for you. And as you can see, it's done one of the tasks, and you can choose to either accept or revert some of those changes. So that's the main thing when we're working with spectrum development. But one of the features is also with agent hooks. So Kira also has this concept, which are essentially background agents that trigger on events like file saves. So while you work, the agents can help you, like maybe you want to generate documentation, create unit tests, or optimize code, or like clean up files, for example. So you see some of the events that it can be triggered by in this demo, whether file creation, file saved, deletion, or of course manually trigger. And you provide the instructions for that particular hook so that it can execute during one of those events. And it's one of a fairly useful feature. It's like having a lot of specialized helpers that run automatically instead of like waiting for you to prompt them every time. And finally, we also have, of course, with context. So that's one of the big problems that we have with LLMs. When you're working with LLMs, they tend to run out of context. So Kiro also helps you handle a much deeper project context, much better than typical AI coding tools. So you can connect it directly to docs, APIs, databases, and other resources through the MCP integration. So agents have real grounded context to work with. And you can also steer how agents behave using the configuration files, as we talked about before. And you can even drop in things like UI mockups or photos of architecture whiteboards, and Kira will use them to guide its implementation. So showing the big picture is with Kira ties in together everything we've talked about today, right? We talked about Bedrock agentic workflows using MCP connectivity and the structure of the AI development lifecycle into more of a development environment that lets you essentially move fast without losing a lot of control in that sense. And that's where we can move on to the workshop. So through this workshop, you'll get a bit more hands-on experience with using Kiro. As well as with Bedrock and our open source agents SDK. So the workshop has a lot of content that we've covered today and a lot of information that we have as well. So do we want to get started with bringing that up, Justin?
What we might do is get people. So I've pasted the workshop link in the chat just so that you don't have to go through and read that very long link and type it in yourself. But we can maybe just take a quick break and go have a look at some of the questions, or if anyone has any questions, maybe field them now, and then we can jump into the workshop as people begin to start slowly signing in. There will be some changes we'll need to walk you through because as this workshop has been developed, some of the names of services and how you sort of authenticate into Kira has changed. So I'll walk you through those once people have sort of started to sign in. I can see on my side once people have signed in. So once we hit sort of a critical mass, we'll walk through some of those. But in the meantime, happy to field any questions.
Thanks, Justin. So I think there's one question already on the chat by Farshid. So Farshid, how about I allow you to talk and you just say your question? All right, you are ready to say and speak out. Yeah, go ahead.
Hello, everyone. Yeah, thank you so much, Justin and Michelle. That was so helpful. My main takeaway is that the challenge now is not building one agent. It's operating lots of agents safely in production. So moving from AI assisted to AI managed needs some clear permissions like safe tools through MCP, memory, good monitoring. So my question, when a team starts using AI managed agents, what's the very first safety or governance control you would put in place for AI managed agents? Thank you.
If I was to have a stab at it, I think calling out observability is one of the most crucial things. Understanding and really being able to go in and understand what your agent is actually doing is crucial, because without understanding what it's doing, you'll have no way of correcting that behavior. But when it comes to, I guess, creating AI managed agents, I'm going to be honest, I don't know what you mean by AI managed agents. I'll be curious what you mean by that.
Well, based on the like let's say from the some tools that can be considered safe tools in the AI managed. So it can be like running running parts of the work on its own, and take more responsibility end to end, like planning steps, choosing tools, modifying or writing the codes, running the tests, deployments, monitoring, and human just mostly set the goals. Yes. And rather than prompting, yeah, I mean, little prompting or maybe no prompting, yeah.
I understand where you're coming from. Yeah. So when it comes to that sort of thing, I think really taking the time to understand what you want your agent to do, as well as then evaluating the risks of that associated with that action, are probably two most important things I would say. Depending on what you're trying to achieve, the bigger, the more ambitious the goal, the more tools you will likely need to give it access to, and the more fuzzy of a definition when it comes to how you want that goal to be achieved is going to happen. So understanding that sort of end-to-end sort of journey of what either a user would traditionally go through without the agent, and then B, how can that process be uplifted with an agent involved, I think is sort of the interpretation I would have, is how can you most safely and sort of clearly define the behaviors of an agent.
Yeah. So definitely reiterate on what Justin's saying here, but another point about understanding like how your agent works under essentially what your agent actually can do, especially if you're using agents that's like you did not build yourself, whether that's an MCP tool. So MCP tool, what capabilities does that tool actually have? And are you okay with like all the actions that it can take? So usually in a lot of the tools that you use and with Kiro, you tend to, they usually, the first time something is used, you can, it's good to see what it's actually doing, and maybe you'll have to confirm whether or not you are okay with that action. And before you give the AI agent like autonomous reign over doing it. So maybe like you don't want it to always deploy something while when you're trying to fix it, maybe you want to make sure you validate that. So that's not something that you want your agent to have full reign over it. So having a proper like risk profile of like what you want it to be able to do. Maybe you only want it to have read-only access to some documentation, right? And you don't want to like do not modify this documentation. So these are some things that you need to know beforehand, and it's good to have that information passed into the agents, or you can lock down controls of that before you start working with it, essentially. And essentially, it's really like to summarize, it's really just understanding what it can do and making sure you have those permissions defined up front, or like if it's going to perform an action, like have make sure you're in the loop, like you're still in the loop to approve the process, those part of those processes.
Yeah, and it can act autonomously. Thank you so much. Really appreciate it.
Not to worry.
There are a couple of more questions. Meanwhile, we're answering question, anyone, everyone. There's a link in the chat shared by Justin. Please go in, sign in up. I mean, you have to go online, just sign in, and you will in the workshop mode, which Michelle and Justin just gonna start in a few minutes. Meanwhile, the question is from Liming Zhu. There are two questions actually from him. What is the relationship differences between Kiro and Agent Core? That's number one. And does Agent Ops covered by Agent Core?
I think both of those questions would probably actually best be answered once we get into the workshop itself.
Yeah, okay.
At a high level, Kiro is a software that you run on your laptop to very similar, if anything, it's actually a fork of VS Code. And it's an IDE that runs on your computer and you build not only agents, but whatever software you want. It is open to the public. There are subscriptions, and as a part of this workshop, you get access to an enterprise subscription of it. But you can also sign up personally to build out any software you want. Where Agent Core is a very much a specialized AWS service that you use in the AWS console, like other AWS services like EC2 or S3, to create agents based off common open source libraries for agent frameworks, be it Strands is the popular one that we use within Amazon, but you can also use other ones like CrewAI and LangGraph. That's the core differentiator, is Agent Core is really for that end-to-end process of building, deploying, optimizing, reviewing, monitoring, and giving access to different tools and capabilities to agents. Which I think sort of covers what Agent Ops sort of is that sort of operations around the development and improvement and optimization of agents over time.
Yeah, sounds good. Helen, I think you have a question around cost. Maybe I unmute yourself and you can explain this question, because I can see there could be so many answers and so many questions can be asked. So I'm going to allow you to talk and feel free to ask this question. If not, then I can read it for you.
Thank you, Avinash. Thank you, Justin and Michelle, for this very informative talk. Supposing we develop an application with multi-agents, because that's been developed in this kind of defined environment with very convenient with convenience. But after the application is developed, what will happen next? The developer needed to deploy the application in another hosting environment or just in the AWS cloud.
So with specifics to this particular workshop, so this environment will shut down after a couple of days. There'd be no cost to you. But if you wanted to go off and create agents in your own AWS account or in your own AWS environment, there would be a cost, yes. There are free tiers that people can use depending on the service. There are a whole bunch of different services. AWS has over 200 different services that you can use. So not every single service is covered under a free tier, but you can go off and build applications leveraging some of the concepts that you've learned today in your own environments after the fact.
Okay, great. Thank you.
Thank you.
I also work with the IT team within UTS. So if you are interested in exploring some of these, feel free to send me an email.
Sure. Okay, great. Thank you.
Thank you, Justin and Helen. Then I guess we can dive into the workshop. I hope some of these participants have joined in, Justin and Michelle.
Yes, I can see a few participants on our side.
Okay.
If we won't spend too much time going and sort of walking you through every single step of the workshop, because
Sounds good.
most of this workshop is really self-service and really understand the environment for yourself, feel free to try break things. Worst comes to worst, you can always sign out and sign in with a different email and you get a whole fresh environment. And there's plenty of accounts for people to use for today. So what I'm going to do is I'm going to change my screen share over to my web browser. So when you sign in, you're going to get presented to a screen similar like this when you put in that URL, and then you can review and sign up for the workshop.
I think
Once you've
in the presentation at the moment for the screen share.
sorry. How about now?
So good.
Cool. So this is what you'll be presented with once you've signed into the workshop. On the left, you will have the sort of agenda for the day and all the different modules and topics that will be covered. It is recommended that you do these in sequential order. Some parts may depend on others, so especially the prerequisite section. And then on the bottom left here, you can have Open AWS Console. This is how you're going to log in to the AWS account that you're going to be using as a part of today. If there are any AWS aficionados in the audience, I'd recommend re-signing out of any personal or work AWS accounts first, just so that you don't get the two environments conflated. But once you click that link, you'll get presented with a new tab that takes you into a AWS account. In the past, when I've worked with other customers, usually it's easiest when you have on one screen or one side of your screen AWS console, and then the other side have your workshop. You could also, down the road, replace your AWS console with the Kiro application when we install that very soon. But as you go through, you'll be able to look at the workshop, work through some of the content, have a read of some of the different material. A lot of this is what we've covered in today's presentation. They sort of come in hand, but we've also done some customization of the presentation for today's audience. But there's a lot of parallels that you'll be able to draw between the two different ones. It'll also work through some of the different labs that you can do as a part of this. So I know we've only got an hour left, and we have more than an hour worth of content. But like I said before, you're able to use this environment after this session is over, and you're more than welcome to play around with this for a few days, specifically 2 hours and 22 days. Unfortunately, we can't extend these environments beyond these 3 days, though. So please don't put anything important in these environments. There's no support or able to get your information back if you upload it to S3 or one of the other data repositories. Please don't put anything sensitive in these environments. You don't control these. We don't want your data. So yeah, please bear that in mind when you're leveraging these services. But once you get into here, we're going to get into the prerequisites. So I'd like to sort of apologize in advance. The content of this workshop was developed before some key changes in our service offerings. So when you go through this process of setting up your enterprise subscription for Q Developer, this is now Kiro in the console. But I'm more than happy to sort of walk you through quickly what that sort of difference is. If you've already gone ahead, you would likely be able to get through it. It's not too different. Just some of the names have changed and the services in that have changed, but the core workflow is very much the same. So within the console, you would like to search for Kiro. Kiro being the agentic AI application that we've talked about earlier. Because Kiro operates its inference in one of our different regions, where we have multiple different AWS regions, where we have data centers all over the world. But in this particular case, Kiro is only available in North Virginia or Frankfurt. For geographic proximity, we're going to pick Virginia. Once there, we're going to get redirected into the Kiro page. We're going to be using Enable for small teams because Kiro.dev is for the individual subscriptions. But we want to get you access to the enterprise version for this lab. Once this loads, enter a personal email address so that you'll be able to access the the login, and then just the name and the first name and last name. Then once that's done, you want to hit enable. And then you're going to need to sort of keep these variables on hand, because when you download the Kira application, you're going to need these links. But that's most of that section done. And then from there, you can get straight into either, you can operate this way in two ways. If you don't want to install Kira onto your personal machine, you can work around that. It is a more difficult and probably longer-winded option. So that option is there. And the other option is to install Kira to your own device. This is going to be likely a bit simpler. But when you do log in, you're going to need the organization identity, which is those little URLs that I was showing off earlier. So in this case, your subdomain AWS apps is this one here in the top left, or top right, sorry. But from that point, you should be able to proceed on your own completely. There isn't too many of us here today, so we should be able to field any questions if you get stuck. But from there, once you've downloaded Kiro and you've got it set up, you'll be able to step forward into some of the other labs and start working through actually creating your first application and interacting with Kiro. I'm going to stop the screen share there and go from there.
So I see we do have a couple of people that have logged into those environments. What we can do for the rest is that we can either have you go through and walk through the workshops on your own. So you'll have our access to our emails, so you feel free to ask us if you have any questions while you're working through the workshops. So these are, as Justin said, like these are workshop accounts that you'll have access to for 3 days.
Right.
For 3 days. So, and after that, the account gets completely wiped. So, you can have a play around in the AWS environment. It's up to you.
And if you want this environment again, we can't do ourselves, right? We can't have this temporary version of a environment to go through this workshop kind of a content. I mean, I know it's a reset again, but can it reset and can be used again? No. We just have no access after that.
What I can do is I can send you a link with just the content of the lab without the actual infrastructure attached. It might be a bit confusing because sometimes it might link directly to things in the console. But everything in here isn't really too, like the resources deployed in your environment are incredibly minimal, if I think any at all. So there's no reason you couldn't do this or follow along yourself. But yeah, I'm more than happy to send that through.
So Helen have one quick question. Where can I get started? So there's a link in the chat, Helen. I'm not sure if you're able to access that. Let me paste it again. Maybe sometime it give you alert.
Was it to host and panelists? Is it?
Yeah, okay. Michelle just pasted a link. And I can paste the link in the questions as well. So you have a link access there. Okay, I hope you can. Oh, okay, great. Thank you.
Is anybody not able to get access? Like, feel free to just pop in the chat.
Yeah. And yeah, like Justin said, so we might also have access of the content, maybe not necessarily console itself later on. So we're happy to share it to everyone as well later on after the software week and when we share this video as well. So just in this video, gonna share So just getting confirmation that you are okay with that.
Yeah, should be fun.
Okay, that's good. One question, meanwhile, I can ask. I know you say Kira is a fork from Visual Studio Code, VS Code, right? And you're using Vibe Code. Is it the case?
So
There's
go on, Michelle.
that's right. There's two modes that you'll see when you open Kira up. The first is the vibe coding mode, and that's not too different from any maybe like if you use any other coding applications, AI coding applications. So it just takes a more approach. And then there's the spec-based approach, which is what we've talked about today, where it helps you create specs, which are more guiding documents and a lot of those that help you streamline more of your development workflow.
Understood. Why I asked the vibe coding, because GitHub Copilot is also another alternate version of Copilot. I mean, do the AI-based coding. Just wondering, I mean, from your perspective, vibe coding and the GitHub Copilot, how do you compare and contrast these two? Just curious.
They're very to Kiro or to the spec driven.
I mean, even in the Kiro, I mean, VS Code, for example, GitHub Copilot is quite popular, but I don't know, maybe it's popular, it's not, I'm not sure, but definitely that's always one option. And the vibe code, of course, you can have as well. So
Right.
in context of Kiro or in general, using coding based assistants, I'm just curious, what's your opinion? Or I should say AWS or Kiro let you also use GitHub Copilot or something like that? No.
Right. So with Copilot, I haven't worked with any in-depth Copilot features, maybe apart from just the standard, like ask Copilot a couple of questions and let it create a function or create a test for you. So I haven't worked, if they've released any newer updates, I'm not too familiar with them at the moment. But the main differentiator with Kiro is really the spectrum part, as well as the other, how you can easily integrate a lot of the other components. So we've talked about how you have a centralized, you can easily, it provides an easy way for you to manage your context. So you have a particular set of documents that Kira can, it's a more guided approach to help you create and manage what is happening in your project, right? So maybe you've had an experience with your AI code editors where you're working on a project, but when you try to work on it next time, you need to ask it a bunch of things again just to make sure it's understanding like what you've created, and then it needs to go through that process again, right? So to analyze your repository again, analyze all the things you've created, and like what have you done, and at times, sometimes that probably overloads the context of a large language model, and it starts to get a lot more hallucinate a lot more, as like a lot of these LLMs do, right? So with Kiro, it's similar, but it takes a more like opinionated approach to that process by making sure that you have the documentation there first.
Yeah.
Right. So you have those documentations ready, you have all of those assets and planning ready for you so that it's all there and for you to review before it executes on them. Right.
Right.
And then, of course, you have the other features with the agent hooks. So that makes a lot of the process easier. If you have repeated processes, that's a way for you to have them run automatically in the background, and an easy way to connect to MCPs as well.
Understood.
Kiro is just one of the many different options in this sort of space. There's also an accompanying Kiro CLI. So if a lot of developers aren't as fond of giving up VS Code, or maybe they're a bit more, I use the word edgy, if they like, Vim or Emacs or NeoVim and some of these other sort of IDE indifferent experiences, they might want a CLI tool. So we have the Kira CLI, which gives you sort of that same access to the Anthropic models to do agentic or even just Gen AI assisted development. But there's also even alternative options. There's Claude Code, but on the back end, you can use Bedrock as your inferencing sort of engine for accessing those models. So there's a whole bunch of different options you can go down. Kira is not the only option, but it depends on what your sort of your preference is, your flavor is, or what the task you're trying to achieve is. If you're trying to create a big, if you're in a more larger enterprise space and you're trying to create big revisions to an application where you need all that context of what is the scoping document required for this feature, what is the expected deliverable, Kira is great in that sense because you're able to give it all that context, formulate a plan and execute. Or if you want to bring a whole new application to life and you really want to get other people involved who want to give you that context of what they're envisioning, it's great in those use cases. But if you want to simply just change a button to be blue and you don't know what the hex code is of blue, and you just want to ask it a quick question, you probably don't need to spin up Kiro every single time or use a spec-driven development for a large such a feature. You can go the more vibe coding route and just ask it in simple questions. And the whole advantage of Kiro is that because a lot of things like Copilot or GitHub Copilot or our previous extensions in this space, they're just extensions. They don't really integrate that end-to-end experience, and you can't do that just within the bounds of an extension. That's why we went this route of creating Kira and having this whole agentic experience, because we wanted to break out of the bounds of what you can do with just an extension.
Right, understood. I think we have someone facing some problem. Helen, you can talk. You can unmute yourself and just speak the question because
Thank you, Avinash.
Yeah.
Probably I accidentally land in a page called billing and the management page, then say access denied. And I now figure out the right ones. So probably, yeah, just
As likely expected, you don't get full administrator access as you typically would within your own AWS account. So some services and access to some features are simply just not enabled for traditional workshop participants. You might still be able to see how much this lab is going to cost, maybe slightly down the line. In normal environments, it might take a day for that billing page to first work. So I don't know exactly without actually logging into your account, but it shouldn't get out of your way.
okay. Okay, thanks. I just steer back to the right track. Thank you.
Yeah, these
Okay.
environments are meant to be quite free, but not completely free in terms of what you can do.
Fair enough. That makes sense.
Shall I use in the personal email address or the UTS email address?
Whatever email address you feel more comfortable.
Okay. Yeah, thanks.
If anyone else have any question and you want to speak out, you can even raise your hand and I can unmute yourself and you can talk if you like, or we can spend up to Justin and Michelle, we can spend few more minutes and we just maybe wrap it up if you like, because we can follow it through because there's a lot more content online anyway, and we have access for about 72 hours, about 3 days, as I can see. Well, to be exact, different. Maybe few less hours than 72 hours. So we can also follow it through, and maybe we can also reach out to you. I think Justin, you mentioned if we have any question, Justin and Michelle. Okay.
So I think I might take this time then to, at Amazon, we say feedback is a gift, and we really mean it. So we would really appreciate to hear from yourselves, I guess, how you found today's session. So if you kind of take the time to maybe spend a couple minutes just scanning that QR code and just leaving us some feedback. It's a very short survey. It's maybe 4 or 5 questions just on how you found the content, how you found us as speakers, how you found in the workshop, just so that we can do better. We want to make every single presentation we do better than the last one, and we only know how to do that with the generous feedback that you provide. But if you could give us that feedback, we'd greatly appreciate it. But other than that, thank you very much for hosting us. I've popped both myself and Michelle's email there, so feel free to reach out to us if you have any questions around the workshop. And yeah, thank you very much for having us. It's been great to be a part of UTS Software Week.
Thank you very much.
Thank you, Justin and Brian. Justin, Brian, and Michelle, sorry, not Justin and Brian. And anyone have any last question? Otherwise, we can wrap it up. And you have all the links with you, as well as Justin and Michelle's email as well. You can reach out to them while you're following through the tutorial and sorry, the content provided by them on AWS. So which is free for next couple of days for walkthrough. And again, if you even have issue beyond that, we still can reach out to Justin and Michelle for any question.
So I've just popped the survey link and our emails in the chat if anyone wants to have easy access.
Excellent. Okay. All right. Then maybe we just said thank you to Justin and Michelle for your time and showing us what AWS potentially can do, and maybe we can have our hands on to try that as well. Thank you. And to all
Thank you very much.
we have 2 more days to go for this part of Software Week. Tomorrow we will be having a talk again and followed by a workshop. So stay tuned and join the link provided to you. I believe there's a communication going on to you.